diet. Today, we're going to talk about the Krebs cycle.
Cycle follows glycolysis in the respiration process. The pyruvate enters the mitochondria where the oxidation of glucose is completed. Once inside the mitochondria, pyruvate undergoes a series of enzymatic reactions, removing carbon dioxide and oxidizing the remaining fragment, forming NADH from NAD+. The product is a 2-carbon molecule acetyl-CoA. Acid, or the Krebs cycle, oxidizes organic fuel derived from pyruvate. Pyruvate is broken down into 3 CO2 molecules, including the molecule of CO2 released during the conversion of pyruvate to acetyl-CoA. 1 ATP is produced by the cycle per turn by phosphorylation, but most of the chemical energy is transferred to NAD+ and a related electron carrier, the coenzyme FAD.
The citric acid cycle has 8 steps, each catalyzed by a specific enzyme. For each turn of the cycle, 2 carbons enter in the reduced form of an acetyl group and 2 carbons leave in the oxidized form of CO2 molecules. The acetyl group of acetyl-CoA joins the cycle by combining with the compound oxaloacetate acid, a 4-carbon molecule forming citrate or citric acid, a 6-carbon molecule.
This regeneration of oxaloacetate makes this process a cycle. The process of turning the 6-carbon acetyl-CoA back into the 4-carbon oxaloacetate is what results in the release of the 2-carbon molecules for each turn of the cycle.
Now let's count the energy-rich molecules produced by the Krebs cycle for each glucose molecule. For each acetyl group entering the cycle, 3 NAD+ are reduced to NADH, but really the net is 6 NADH because there are 2 pyruvates resulting from 1 glucose molecule, and each one produced 3 when it went through the cycle. In step 6, electrons are transferred to FAD, which accepts 2 electrons and 2 protons to become FADH2, and the net production is 2 FADH2. Step 5 produces GTP, or guanosine triphosphate, which is very similar to ATP. Step 5 forms an ATP molecule directly by phosphorylation. It does not include the 2 NADH molecules produced from the beginning of the Krebs cycle and after the end of glycolysis in the oxidation of pyruvate in order to prepare it for this cycle. Therefore, it can also be said that 8 NADH molecules are actually produced after glycolysis, even though the oxidation of pyruvate is an intermediate step and not directly part of the cycle. The Krebs cycle is also unique in that it is where other macromolecules such as proteins and fats can be introduced into the respiration process. They can be broken down into acetyl-CoA at the beginning of the cycle and go on to produce energy. Carbohydrates are not the only molecules that can fuel this cycle. The Krebs cycle is important in producing the high-energy electron carriers needed for the electron transport chain in the next step of respiration. A net of 4 carbon dioxide molecules, 2 ATP molecules, 2 FADH2 molecules, and 6 NADH molecules are produced from 2 molecules of pyruvate derived from 1 glucose molecule. The ATP produced by respiration results from oxidative phosphorylation, which occurs as a result of the NADH and FADH2 produced by the Krebs cycle relaying the electrons extracted from food to the electron transport chain. This leads to the next process, the electron transport chain, for which the outputs of the Krebs cycle, NADH and FADH2, are the inputs for it. Overall, the citric acid cycle, or Krebs cycle, is an essential part of cellular respiration and in the breakdown of food into energy.